Okay, so good day to our Mahati Science High School students. Let's move forward to our fourth lesson for the first quarter. We have quadrilaterals. Okay, so for this problem, we have here, in the diagram below, ABCD is a rectangle. What is the length of EG? We have a triangle inscribed inside of a rectangle, and we need to find the measurement of this length from this point G to point E, this line segment. Given that we have here that DC is equal to 6 plus 2 square root of 3 units and BC is equal to 8 square root of 3 units. So for the first one, our first given states that ED is equal to 2 square root of 3 and BG is equal to 2. Okay, so we want to know if this information is sufficient for us to solve the given problem to find EG, and as well as for the second evidence. Okay, so for the first one, let's try to use these givens that we have here. Okay, so for the first one, if this is 2 square root of 3 and A is missing, and we know that this is 8 square root of 3, and it's a rectangle, so what are the properties of a rectangle? So we have parallel sides that are opposite to each other and are congruent to each other. So this 8 square root of 3, most likely this would be 6 square root of 3. Now we have here 6 and then 6 square root of 3. We can also solve for the value of this side. Since we know that this is positive 6 and this is already 6, so since they're parallel to each other and are congruent to each other, it says here it's 6 plus 2 square root of 3. Most likely this would be 2 square root of 3 as well. Okay? So using the Pythagorean theorem, we know that this is a rectangle, and we know that in a rectangle we have right angles. There you go. Using the Pythagorean theorem, we can solve for the measurements of these sides on this right triangles that we have. So for the first one, we have here on triangle AFE. Okay, so solving for EF or FE. Okay, so that's gonna give us A squared plus B squared is equal to C squared. So we have the Pythagorean theorem. So that's gonna give us 6 squared plus 6 squared of 3 squared is equal to C squared. Now we can simplify this. So 36 plus, okay, so we have here 6 square root of 3 squared, so that should give us 108. 36 plus 108 is equal to C squared. 108 plus 36 is equal to 144. And if we divide, or if we take the square root of both sides, therefore C, or EF, is just equal to 12. Okay, so that means that this is 12. Okay, so we can now solve for the measurement of the other hypotenuse of the right triangle that we have here at the bottom. I'm sorry. Okay, so for number 2, we have here for triangle FBG, we're going to solve for FG or GF. Okay, so using again the Pythagorean theorem, we have A squared plus B squared is equal to C squared. We're going to have 2 square root of 3 squared plus 2 squared is equal to C squared. Using your calculator, so this should give us 2 square root of 3 squared, so that should give us positive 12. 12 plus 4 is equal to C squared, so this is going to give us 16 is equal to C squared. And if we take the square root of both sides, so therefore C or FG or GF is just equal to 4. So that means this is 4. Okay, so we have here the side measurements of our triangle. Now there is an advanced lesson that we're going to discuss on the third quarter. So we call them special right triangles. Special right triangles. And one of the patterns in the special right triangle is the 30-60-90 triangle. The 30-60-90 special right triangle kind of looks like this. It's a right triangle, it's any right triangle, but it has 2 special angles. There's a 30-degree angle here, and there's a 60-degree angle here. And according to the formulas for the 30-60-90 special right triangle, the opposite side of the smallest angle, which is 30, should be x. The opposite side of the second, or the larger angle, I'm sorry, should be x squared root of 3. And the opposite side, opposite to the largest angle, which is 90 degrees, should be 2x. Okay, so if we're going to look for the pattern, the coefficients have patterns themselves. Okay, so the opposite of 30 is 1x, so that's the coefficient of it, the numerical coefficient. The opposite of 60 is 1x squared root of 3, and the opposite of 90 is 2x. Now, if we're going to look for a pattern here, if we try to look closely here at triangle FBG, I'm sorry, let's try AFE first. On triangle AFE. Okay, so what are the patterns that we have for triangle AFE? We have 6 squared root of 3, and 12. Now, this pattern, it's the same as the ones with the side measurements that we had here. Now, if the patterns here are the same from the 30, 60, 90, and the side measurements for triangle AFE, therefore we can conclude that the angle measurements of triangle AFE are 30, 60, 90. But which is the 30, which is the 60? We know that this is 90, but since this is 6, this is the smallest side, this must be 30. Okay, and this must be 60. There you go. Okay, and we also have another 90-degree angle here, but what's gonna be the pattern? Okay, so let's try to write the pattern. Again, that's 2 squared root of 3, and then 4. Now, which is the 30 and which is the 60? We already found the 90, just have to find the 60 and the 30. So since this is 2, this must be 30, this must be 30 degrees, and this must be 60. Okay, we're going to use a different colored pen, so it's a bit more apparent, conspicuous, so you can see it readily. Okay, so we have your 60 degrees, and then we have your 30 degrees. So since this is a straight line, then the sum of the angle measurement, okay, the sum of the angle measurement for this straight line should be 180 degrees, right? So this should be 180 degrees. And if this is 180 degrees, and this is 60, and this is 30, what's going to be the measurement of this angle, the angle in between 60 and 30? So that's going to give us 180 minus quantity 60 plus 30. So that's going to give us 180 minus 90. And what's 180 minus 90, guys? So therefore, that's 90 degrees. There you go. So it turns out that this is a right angle. There you go. And if that's a right angle, okay, if that's a right angle, I'm going to use a different colored pen so you guys can visualize it a bit better. Okay, so let's try to use green. Now, if this is 90, most likely this is going to be a right triangle. Okay, and we already know that this is 90 degrees. It's a right triangle. And we already know its side measurement. One of the side measurements is 12, and the other is, this one's 4. There you go, so that's 4. We just need to find the measurement of this side. So using the Pythagorean theorem for the third time, we're going to use the Pythagorean theorem for the third time. This time, since we've already established that we have a right triangle, so let's write here, for number 3, we have triangle, what's the name of this triangle again? Wait, let me erase some parts. Let me erase this. So that's F. Okay, so we have here triangle FEG. So for triangle FEG, okay, so we have here, okay, FEG is a right triangle. And if it's a right triangle, we can absolutely be certain that we can use the Pythagorean theorem. So that's a squared plus b squared is equal to c squared. We already know it's two smaller sides, so that's 12 squared plus 4 squared. That should give us the hypotenuse, which is EG squared. And what's 12 squared? So that's 144 plus 4 squared, so that's 16, is equal to EG squared. What's 144 plus 16? So that should give us 160. 160 is equal to EG squared. And what's the square root of 160? So the square root of 160, so that's 4 square root of 10. So we can factor 160 to 16 times 10. And since 16 is a perfect square, you can take it out of the square root sign. So therefore, EG is just equal to 4 square root of 10 units. And therefore, we solve the problem. EG is equal to 4 square root of 10 units. Okay, but for number 2, if we're just gonna rely, okay, so number 1, it had sufficient evidence. But for number 2, try to look at this given. If we're just gonna rely that this is 90 degrees, and let's say for example that this was not given, ED and PG, the values for ED and PG were not given. Therefore, we would have insufficient data or insufficient evidence to find the value of EG. Okay, so that is why, okay, for our problems, the given information must be sufficient in order for us to find specific side measurements. And for the first one, it worked. Okay, so for the first one, the side measurement is just equal to 4 square root of 10 units. And that's how we solve this problem.